Welcome back to Geology Info. A magnitude 7.0 earthquake, later revised to 6.7, struck Indonesia and was felt as far away as Australia. Indonesia, an archipelago of more than 17,000 islands, is located in one of the most geologically unstable zones on the planet, the Pacific Ring of Fire. This region is known for its intense seismic and volcanic activity, a direct result of the movement of multiple tectonic plates. Within this area lies the Banda Sea, home to the Viba Basin, a unique geological formation that is extremely deep and enigmatic. In this setting, large magnitude earthquakes frequently occur with significant historical records, such as the megathrust earthquake of 1629 that generated a tsunami of approximately 50 feet, 15 meters, in height. Recently, another earthquake hit the same region, with a recorded magnitude ranging between 6.7 and 7.0 depending on the seismic agency. The tremor was so powerful that it was felt all the way in Australia, emphasizing the strength and reach of the event. The exact location was near the ocean floor around the Tanimbar Islands, a chain of 30 islands situated in the Maluku province of eastern Indonesia. Despite its strength, there were no immediate reports of major damage or tsunami alerts, which comes as a relief given the area's history of natural disasters. The region's past includes alarming events, such as the January 2023 earthquake, which struck the Tanimbar Islands with a magnitude of 7.6. At the time, the population panicked due to a tsunami warning that remained in effect for several hours. That earthquake caused material damage to at least 15 homes and 2 school buildings. Interestingly, following the event, there were reports of a new island appearing, likely formed by the release of mud trapped between tectonic plates or possibly a mud volcano. Geologically, this area is highly complex. The Australian plate moves northward, subducting beneath the Sunda plate, which is part of the vast Eurasian plate. Additionally, the Banda Sea plate, considered a microplate, acts as a buffer between these major plates, which further intensifies the local seismic activity. All of this occurs in a critical segment of the Pacific Ring of Fire, where not only earthquakes are common, but also intense volcanic activity. The Viba Basin, where the recent earthquake occurred, is a rare geological formation. It is a forearc basin with extreme depth, reaching nearly 4.5 miles, 7,200 meters, making it the deepest part of the ocean that is not located in a trench. This feature makes it unique in the world. Its depth is not due to a typical oceanic trench, but rather the result of intense tectonic extension caused by subduction rollback and the presence of a massive low-angle fault known as the Banda detachment. Recent studies have revealed that this fault, the Banda detachment, is likely the largest exposed fault on Earth. It stretches for approximately 75 miles, 120 kilometers, and caused massive subsidence of the oceanic crust, forming the present abyss. Rocks from the Earth's mantle have been brought to the surface, indicating the extreme level of tectonic extension the crust has undergone. The exposed surface of this fault covers more than 23,000 square miles, 60,000 square kilometers, an impressive area that allows scientists to better understand the tsunami risks in the region. Now that this latest earthquake struck right in this area, experts are questioning whether it was the main shock or just a foreshock of a larger event to come. The geological history and tectonic complexity of the location keep the scientific community in a state of constant alert. And, for good reason, we are talking about one of the most seismically active and mysterious regions on Earth. As we dive deeper into the recent events around the Tanimbar Islands, it becomes impossible to ignore the geological magnitude of the region. This part of the world, located in the heart of the Banda Sea, is constantly pressured by the titanic forces of tectonic plates. The ongoing interaction between the Australian plate, the Sunda plate, the Banda Sea plate, and additional influences from the Philippine Sea and Caroline plates makes this region a true seismic cauldron. With each new tremor, the Earth's crust there reveals another chapter in its deep and still poorly understood history. Images captured from the ocean floor after the earthquake show a surface marked by parallel scars, indicating that enormous blocks of oceanic crust were stretched to their limits. These formations reveal that a section of crust, larger than the territory of Tasmania or even Belgium, was pulled apart by about 75 miles, 120 kilometers, creating a massive depression in the seafloor. This fissure, now named the Banda Fault, is a direct result of the extreme tectonic extension that shaped the ocean landscape we see today. The discovery of the Banda Fault only occurred in 2016, highlighting how little we still know about the depths of our oceans. The fault is exposed over a colossal area, and its study has enabled geologists to better understand how the basin became so deep. The presence of rocks from the Earth's mantle near the surface shows the force with which tectonic plates acted here. This type of extreme deformation is rare and, when identified, raises serious questions about the risk of future earthquakes and tsunamis. The recent earthquake was quickly followed by secondary tremors, known as aftershocks, with magnitudes of 4.4 and 3.6, which was expected given the area's instability. Before the main quake, There was also a foreshock recorded at magnitude 5.2, reinforcing the idea that this fault system remains active. Experts continue to monitor the situation, trying to determine whether the main event has already occurred or if stronger tremors are still to come. What is most impressive about this entire process is how science evolves with each new earthquake. The data obtained from the study of the Banda Fault helps refine seismic and tsunami risk models, not only for Indonesia, but for the entire Pacific region. The hope is that with this data, more accurate warning systems and more efficient evacuation plans can be implemented, potentially saving countless lives in future events. Meanwhile, residents of the Tanimbar Islands remain alert, remembering past events and aware of the dangers that lie beneath their feet. Despite the apparent calm after the quake, the fear of new tremors persists. The scientific community remains vigilant, hoping that this event was not a precursor to something greater. Nature has already shown what it is capable of in this part of the world, and everyone is paying close attention to any new signals coming from the ocean's depths. In this context, it is inevitable to reflect on the sheer power of nature and how much we still need to learn about the processes that shape our planet. The Banda Fault, being the largest exposed fault known on Earth, marks a milestone in the study of modern geology. Its discovery not only expanded the understanding of plate tectonics, but also raised an alert about the hidden dangers that regions like this present. It is uncommon to find such a gigantic and active structure in such a sensitive location. Given the region's geological complexity, events like this remind us of the importance of investing in science, monitoring, and seismic education. Every new image, rock analysis, and seismic record helps to complete a puzzle that could be crucial in predicting or mitigating future natural disasters. The hope is that through knowledge we can reduce the human, material, and environmental impacts of phenomena we cannot avoid, but can understand and prepare for. Although there have been no reports of loss of life in this latest event, the fear of something bigger still looms. The Tanimbar Islands, with their natural beauty and resilient population, have already faced other traumatic episodes in the past. What makes them vulnerable also deeply connects them to the planet's dynamics. Every tremor is a living reminder that we inhabit a constantly shifting Earth, moved by invisible and intense forces. The recent discoveries about the Banda Fault and Viba Basin also reveal how little we know about our own oceans. Most geological studies still focus on solid ground, while the seafloor, which covers more than 70% of Earth's surface, remains a mystery. It is in these depths that we find valuable clues about Earth's inner workings, including the places where the greatest tectonic tensions accumulate. That is why these events must serve as catalysts for further research. Geologists, seismologists, and oceanographers around the world are turning their attention to the Banda Sea and the Tanimbar Islands in search of answers that could directly impact the safety of millions of people living along the Pacific Ring of Fire. The region remains a natural laboratory, where every seismic event represents a new opportunity for learning. And if you made it this far, it's because you are interested in topics that directly impact life on our planet. So don't forget to like the video, subscribe to the channel, and turn on the notification bell to receive more content about the natural forces shaping our world. Share this video with someone who also needs to understand the hidden risks and mysteries beneath our feet. See you next time.